Hello, everyone. I extend a warm welcome to each one of you joining us today. I'm Hemangi Chowda, and it's an absolute pleasure to be your host and moderator for this insightful webinar on Telep ADAS by Teksun. Today, we embark on a journey through automotive safety and innovation. Telep ADAS stands as a testament to the tireless efforts of our team at Teksun, where innovation converges with cutting edge technology to redefine the landscape of advanced driver assistance systems. Our aim today is to showcase technology and provide you with a deeper understanding of how Telep ADAS can transform driving experiences and pave the way for the safer future. If any questions come to mind during the presentation, don't hesitate to write them in the chat or keep them for the interactive question and answer with the presenter once the presentation concludes. For those eager to delve into ADAS and driver management system development, this webinar assures an enlightening and informative session filled with valuable insights. All right, everyone, we are all set. Um, Meet our expert, Mr. Mohit Agarwal, who is the speaker for today's webinar. I'll now hand it over to Mohit to introduce himself.
Hello, everyone. Good morning. Good evening to all of you. I'm Mohit Agrawal, CTO at Texan, and I'm bringing across an 11 years of experience in domains such as satellite communication, security and surveillance, and automotive segment. And today we are going to particularly discuss upon the ADAS technologies into the automotive segment. Just give me a moment. I can present my screen and we can take it forward from there. I hope the screen is visible to everyone.
Yes, it's visible.
Yes,
Thanks, Mangi,
visible.
for the confirmation. We'll take it forward from here. So, yeah, before dwelling into the ADAS and what Texan is doing in terms of Telip AI libraries for the ADAS solutions, I'd like to give you a brief overview of the company, who we are, what Texan is. Texan is an IOC 9001 2015 certified company. It was established in 2014, and we are a strong group of 300 plus IoT plus AI engineers, and the verticals that we are working in is embedded hardware, embedded software, artificial intelligence, product design and services, product certifications, and even the manufacturing side of things. So Texan over here is with a mission of to provide innovative and affordable high-tech solutions to global society. And the vision is building revolutionary technology which benefits everyone, and ADAS is one part of it. As discussed, particularly on automotive side, we have done 100 plus automotive projects and successfully delivered them over the segments as connected car and edge AI, DMS, which is driver monitoring system, vehicle telemetry, V2X, digital cockpit, ADAS, and predictive maintenance. The focus of today's webinar would be on the sides of DMS and ADAS particularly. As part of introduction that Texan is a vertically integrated company and has three dedicated business units. There is embedded systems, under which IoT product engineering, multimedia systems, RF and high-speed design, firmware on Linux, RTOS, AOSP, edge computing. Similarly, on the artificial intelligence, which is crux of today, we are able to do artificial intelligence with NLP, machine learning, predictive maintenance, computer vision, ADAS TMS, healthcare engines. And similarly on IoT side, we are huge on IoT enabled services as well, which consist of full stack web development, blockchain, mobile applications, RPA, DevOps services, and enterprise applications. This is a brief understanding on sides of how do we engage on product engineering. It's through dedicated team, time and material, fixed scope. Apart from product engineering, we are into contract manufacturing, where we can take your design products to the market and take care of the mass manufacturing aspects as well. Yeah, so we have gone through the introduction of Texan. Now I like to jump directly to the AI aspects of thing. When it comes to AI, we are invested into particularly five verticals: computer vision, machine learning, signal processing, natural language processing, and recommendation systems. Majority of the discussions that we'll be today having would be under the segment of computer vision, where object detection, object segmentation, image classification, and key point detection. These are the basic models which form like the crux or heart of the ADAS system. Over here is the stack that we use on the AI side, right from OS. All the models that we develop currently are platform agnostic in terms of it can run on Mac, it can run on Android, Ubuntu, and Windows. Similarly, when it comes to hardware, the system can run on Qualcomm, NVIDIA, NXP, Synaptics, Quectel, BrainChip. And apart from that, all those models that we have made could run on GCP, AWS, or even Azure. So all the Telip library models are platform agnostic, both from the hardware and software perspectives. Here are the key tech stacks that we are using on data processing libraries, model training frameworks, model optimization. So these are the key ones when it comes to make your model like feasible so that it can be transformed to other ecosystems. TensorFlow Lite, STM32, TinyML, ETA Compute, and Edge Impulse are our partners through which we are able to transform the existing models to work on any of these hardware platforms. Then we have runtime frameworks again as Core ML, NVIDIA's Android, Daylib, and Flask. And one interesting part that we have developed at Texan is pipeline automation. We have automated the whole AI pipeline, wherein right from data gathering to model training to model deployment, everything is taken care of parallelly. So any particular use case that we are going to see and in the future you would like to add any ADAS use case to it, it's just matter of data that needs to be feed into our AI model pipelines. Cool. And over here are the few success stories in the automotive segments that we have taken to the market. Our cabin dual display systems. So a lot of companies are coming up who need a like a revamped cockpit solution. So that's what we are providing them. ADAS system. That's what we are going to discuss today. 360 dash cam with a camera facing internally as well as uh, externally to capture the DMS activities, surround view, digital cockpit per se, as in the infotainment system, and predictive maintenance. So this is a huge upcoming altogether topic. We may be doing another seminar on this in detail on showcasing how Texan's solutions are able to predict the challenges in the car upfront and connect the whole ecosystem of the retailer and the OEM as well to enable a cohesive environment to provide better services. So now coming to the main topic and agenda of today is Texan has developed the Talib AI algorithm libraries, particularly on the ADAS side. What we can see over here, the features like as good as 20 features that we have taken care of on the ADAS and DMS is forward collision warning, headway monitoring warning, pedestrian alerts, acoustic vehicle alert, tailgating warning, blind spot detection, predictive crash detection, pedestrian crash detection, lane departure warning, rolling stop warning, traffic light monitoring, park assist, deer detection and alert. So all these are on the DMS side, sorry, the ADAS side. And coming to the DMS, we have done a very innovative solution on the sides of driver health monitoring. It's an interesting use case that we'll be seeing further down into the presentation. Out of all this, we have captured a few of the videos that we'd like to share today on the implementation. That keeping on being mindful of the time, we have selected a few use cases which we can showcase today into the webinar. So driver drowsiness detection, SOS call, mobile distraction detection, driver seatbelt detection, and any other movement detection which is per se going into the uh, driver's distraction as a whole. Coming to advanced driver assistance solutions. So this is something that we are going to discuss on forward collision warning. So this is the most and foremost important use case when it comes to ADAS. What it technically does is it's able to identify on the road the cars, trucks, buses, automobiles, pedestrians, and several other objects on the road, and it can identify if it is getting into our way and there is a potential chance of a crash, so that could be identified. The key features of this model are continuous road scanning, instant collision identification, proactive alert delivery, and a pretty much user friendly interface. So what you could see on this particular side is a photo where you can see this red line is there. So this is a editable markup line where we can identify if in this particular region the vehicle is going to come in or any particular object. It's a state of alarm. Taking a closer look at the video of it. So this is, you could see, as soon as any particular vehicle comes into the designated area, there is an alarm generated. So for demonstration purposes, and currently this being shooted in US, we needed to keep the boundaries bigger to showcase the demo, but the boundaries could be further stringed down according to your likes on that particular system, and the alarms could be ranged accordingly. So now the next, moving ahead, we are on to headway monitoring warning. So what particularly this video would showcase and this feature is about, it's not just that anybody has already infiltrated or like into this particular region of your vehicle, but this could actually calculate the distance of that object from your car right now and how gradually you are approaching and minimizing that distance, which is kind of an important information that for the system. If you talk about assistive braking, right, so this is going to be keeping the system prepared that we may get in another second or two get into the proximity of other vehicles. So this provides you of the distance on that. So again, it detects car, trucks, bus, motorcycle. The main feature is real-time car counting. It can count the number of cars and it can identify real-time distance between the object and our car. And again, an intuitive interface where you can configure it to your likings. So over here, you could see this small block. It is calculating the distance in meters and showcasing how closer the vehicles are getting in the way. Okay. The next one is the foremost important one is the pedestrian crash detection. So we'll be able to like identify if a particular person or pedestrian being the humans as well as animals. Today the video that we have captured is just on the human side of things. So as soon as a car is approaching a human, so we'll be able to get a particular alert on that. Particularly in India and US, both this is like important. In US, there is a rule that a pedestrian first, like if a pedestrian is there, be it any road, be it any particular rules and regulation, the vehicle needs to stop. Okay. So again, the key features of these are continuous road scanning, real-time pedestrian detection, real-time alerts, user-friendly interface, responsive technology, and OT updates have been included in this as well as other features as well. I'll showcase a demonstration on that. Looping through it again on this particular site, that you would see once the uh, person entered into this particular region, then only you would see the red light. Okay. And then moving forward to other features is what we have worked out is we are able to show in the limited time on these three features the videos for them. Apart, we have a tailgating warning, which is like a key importance in terms of security and surveillance domain. I would say more than automotive. There are use cases where there is a boom barrier and a single car is allowed to pass through, but any other car passes through just behind it, which is not an acceptable use case. This is one. And the second thing is, if a car has been following you like for a long duration of a time, so that could be also identified, and if a safety alarm needs to be raised, so that's a different use case on top of this technology that can be integrated. So that's the other use of tailgating. And the third part is also in terms of insurance claim, like when you are driving the vehicle, right, and you are driving at a certain speed and the front vehicle is not giving you any particular way to get ahead of him, and apart from that, if he puts on an emergency brake and crashes, so that kind of informations would be of real help in the insurance claim part. So that's on the tailgating warning. It helps in maintaining a cruise control distance on the application layer. The next one is acoustic vehicle alert. So in case of there is a vehicle in front of you, a visual alert could be generated as well as an acoustic one. Generally, people while driving wouldn't like a visual alerts because those are distracting, but this could be just an acoustic alert where we just provide a beep sound. Okay, so that's proactive alerting, engine noise simulation, safety awareness, and the accuracy is currently at 96% of this. The blind spot detection, this forms a very important use case when it comes to like we general use case is that in a car behind the rear view mirrors are not actually per se able to cover the whole area which needs to be seen by the driver while making the lane shifts and cornering aspects at that particular time. This is a very insightful one. It provides you with an on-screen display on your cockpit. That is part one, so that you could yourself make an informed decision. But apart from that, if anyone is like kind of a motion detection, if there was no one in that particular zone and suddenly someone gets into that zone, you would be of well informed through the visual and acoustic warnings on them. The other one is predictive crash detection. So in this particular case, uh, if the vehicle is getting too close and like slowly and gradually the distance between the two vehicles is not being maintained or like closing in, we can identify or predict a crash is going to happen, so the braking things can happen accordingly. Then similarly on the pedestrian alert that we saw a video, this is again the AI per se remains the same on this particular site, but the application use case changes in form of giving an alert. Then there is lane departure warning, which is a bit of a different use case from the ones that we saw till now. Till now, the majority of the use case fell into the direction of object detection models. The headway counting was a bit of what I can say is 2D stereo vision, where you could find the distance between the vehicle and object. So that was a different segment of a model. And this lane departure detection falls into object segmentation, where you are able to identify the road as a whole and identify a particular lane, and if your vehicle is crossing the lane or not. So it's not a standard use case of object detection, it's into the object segmentation side of things. So any unintentional departures could be identified. In this, majority of the accidents per se in India happens because of lane switching. So if any intentional lane switching is going to happen, the vehicle can act accordingly. Then we have this traffic light monitoring. So slowly and gradually, it's not just the use case of ADAS, it's an whole use case of a V2B segment and V2X segment, vehicle to infrastructure, where in this also you can identify traffic light, the state of the traffic light, and based on that, the vehicle can take actions accordingly. So in case of generally what happens is we tend to miss out a sudden change in the traffic light from green to orange or orange to red. In that case, vehicle can itself identify the red light that has been come, and the braking can happen accordingly, or the driver could also be given a head up warning that now it's red. Generally we get distracted looking at the lights, so this would help in that particular case. Then it's park assist technology, so we can, it's because of the camera behind the car, we'll be able to identify if any object detect, if there is any particular object behind the car that could be tracked. It provides you situational awareness right now to park the vehicle. Currently, it's park assist in the terms that we can identify the object, give you an alarm, guide you on that, but we haven't automated so far on the parking assist. Okay. And this is a deer detection warning. As I said at the start of the thing, that pedestrian doesn't only mean that we'll be able to identify the humans. We are able to identify stray animals that are loitering around on the road. Those could be also detected. And if an braking or alert needs to be done, those two could be taken care of. So that covers majority of the features that we have done on the ADAS side. Now taking you through the driver monitoring system. So on the driver monitoring, we have done a whole lot of activities. The use cases are driver fatigue, which we are able to find through eye blinking, driver drowsiness through yawn. We'll be seeing a demonstration on that. So that's the mobile phone usage detection, seatbelt on detection, driver vital sign detection. We have a video on that today as well to showcase. Occupancy detection inside the car, child pet present detection. So this is an important use case in US currently, because uh, over the years it's been identified that there have been a lot of fatalities in terms of child and pet. People tend to leave out their pets inside the car with the windows rolled up. So now it's been a mandate that that shouldn't happen, and the car should be equipped with those kind of systems. And driving score on CAN data, we are able to capture into the CAN data and look at the driver's actual driving behavior. All of the things that you saw on the top are drivers behavior on the terms of how much uh, of an attentive he is while driving. But the driving score based on the CAN data is the novel algorithm that we have developed based on how he is he accelerating the vehicle too much, or it's an aggressive braking, it's an aggressive cornering. Those kind of use cases could be identified. Is the vehicle owner, the driver, is raving the vehicle too much, which is going to impact the engine in a longer run. So these kind of data are important for the insurance company to provide you a user based insurance. The services, as we started at the start, we provide right from architecture design, as in the hardware design, hardware prototyping, camera driver integration, CAN encoder decoder, AI model development and deployments, system integration and testing. Here are the few partners: the Qualcomm, NXP, Renesas. On the model side, TF, Lite, ONXX. So on the image sensor side, Sony and the OmniVision are the sensors that we prefer to uh, make our systems with. So this is the driver health monitoring system that we are going to see right now. Is what we have done is, if you would be familiar with the PPG technology, it got really popular in the time of Corona. So what we have done is, we have done a remote PPG wherein you can just point the camera towards the face and be able to identify the heart rate of the person, SpO2, and based on the landmarks, you would be able to identify the facial expressions. And apart from that, through the heart rate variability and all those stuff, we'll be able to also identify the stress index of that particular person. So these are the few features that we are currently capturing real time. So what we have done is, we have implemented into the driving scenario, because it is really important to understand the health of the driver. Maybe this is not a use case from a individual perspective, but from a fleet owner perspective, that's an important thing of knowing your driver's health, because they do a long runs of what we can say is 15 hours at a stretch, 20-25 hours at a stretch. In that cases, it's really important to know about their health. So we'll be having details with the timestamp, and currently the accuracy that we are up to 95%. For heart rate, we are landing between +5 to -5 of a variation. Let's see a live demonstration on it. So over here, you could see that we were able to identify the SpO2 as 97% and the heart rate is 82. Facial expression is in happy mood and it's slightly tensed. I'll just play the video again. Okay. And this is again an important use case in driver drowsiness detection. What we have captured right now is uh, the eye blinks and the yawn. So typically, eye blinks and yawn, we are able to do this through the facial landmark detection. We are able to find the facial landmark and put the Euclidean distances on the points and identify the distance between them to identify a activity of a yawn or eye blink. So the system doesn't end there. It's a lot of human engineering that is required to identify if this is the right behavior or not, because there could be an argument if a person is blinking too much, he's sleepy, but that's really not the case. What happens when you are sleepy is, you tend to open your eyes for a lot longer time. You are fighting internally so that you don't close your eyes quite often, and apart from that, if you even close, for how much duration that eye got closed. So all those parameters, we did an extensive research on those sides and crafted out a model on them. Similarly, on the yawn detection, it's been like, if you are singing a song, the mouth opens up wide, it doesn't need to be identified as a yawn. So There are different characteristics to it, so we are able to distinguish between them and identifying all those parts. Let's take a quick demonstration on that side. So you'll see the yawn counter is at 1. It went to 2 again. The eye blinks are consistent. It's generally said a normal human would blink eyes anywhere between 5 to 10 times within a minute. So those parameters captured, and you would see towards the end when a yawn gets to a mark of 3 to 4 yawns within a stipulated time, we see a warning on that particular. Of course, currently we have tried to simulate it, but that's what the human nature is supposed to be. Cool. So I, as understood, the video is done. Now, other models that we have worked out is on the seat belt detection. We are able to identify if the driver is wearing the seat belt or not, and the warnings could be shared accordingly. So that's there. And this particular feature, I guess, maybe it's more important in the fleet industries, where you can identify if driver is behaving that particular way or not. But the same thing, the all the models that you are seeing over here could be put up into a traffic light camera, where from a distance it would be able to capture, and these are technically breaching the traffic laws, right? So based on that, if any action needs to be taken care by the authority, those could be taken care of. So driver seatbelt detection, mobile distraction detection is there, and then any particular movement detection, which would identify as the driver being non-attentive. So yeah, that brings us to the end of the presentation today. We are like really excited to have this particular webinar showcasing our capabilities on the model side. All these models are, again, I would like to emphasize, hardware and OS agnostic, and could be ported on any particular use case or a set of hardware or system that you currently have. Apart from that, if you want to put up any other use case to it, we'll be able to do with just the right amount of data in that data set. The pipelines are ready for, like, you have everything ready on the cloud side as well to integrate the things on the go. Thank you.